Welcome back, everybody. This is our second panel session on fire testing and building control. Thank you all for attending, and thank you all for your questions, which have again shaped how we've shaped this session. My name is Matt Holman. I'm a partner of Gardner and Theobald, and I'll be your chair again today. And I'm ably assisted by Oliver Booth, who's going to pick up on the poll questions and the like. So this is our agenda. We're going to just do a brief overview of where we've been so far. We're going to introduce our panel, get straight into the Q&A on the panel, and then I'll introduce our next session towards the end, which is going to be on sustainability on the 6th of October, and I'll close the session. Okay, so just in terms of last month, hopefully you were able to attend our insurance panel last month, and you can see how we're trying to shape things. You've seen the report that's come out. The recording of the session is available. If that's too much to write down or too much to look at, we'll send you a link again separately if you haven't already got it. And again, the report has been issued, and if you haven't got a copy of that, don't hesitate to contact Ollie, and we'll make sure you get a copy of it. But for now, let's get Ollie on, and he can introduce our panel, which is exceptional today. So Ollie, over to you.
Thanks, Matt, and good morning to everybody. Thanks for joining us. We're very excited about the panel we've assembled today to discuss fire testing and building control. We've assembled some of the leading experts in their respective fields. We know that from the feedback we've had from several of the developers as part of the forum and the insurance panel several weeks ago, along with discussions with the other stakeholder groups, that these are incredibly important issues when designing for mass timber commercial office buildings. Our panelists today are as follows. Judith Schultz is a chartered fire engineer and a director at Arup. Judith has extensive international experience providing fire safety advice through the asset life cycle, from briefing stages through design, construction and handover, and provides strategic fire safety advisory services to a large range of clients. She has worked on many award-winning projects such as the London 2012 Olympics main stadium, the Shard and Sky's headquarters, home to 3,500 staff, and constructed using glulam, CLT and steel to meet the client's aspirations for a super fast, super flexible building. Judith oversees a wide range of major projects at Arup, including research collaborations in fire safety and timber. Judith holds 3 master's level degrees covering fire safety and engineering and safety engineering, fire safety engineering, civil engineering and interdisciplinary design in the built environment, which are obtained in 3 different countries. Judith also generously shares her expertise in many voluntary roles, including membership of the Building Regulation Advisory Committee and the MHCLG as a fire safety expert, to name a few. Our next panelist is Sam Liptrot. He is one of OFR's founding directors. Sam has been responsible for the delivery of some of the world's largest projects over the last 18 years. He has also grown and managed teams of up to 50 fire engineers across multiple countries. Sam is an experienced fire engineer with an extensive knowledge of both the theoretical and practical application of all aspects of engineering. He has delivered bespoke fire strategies on a wide range of local, national and international codes and standards. His primary skill is coordinating safe, efficient solutions across multi-stage projects from initial planning stages to occupancy and tenant support. Sam's understanding of how fire engineering impacts on other disciplines and knowledge of when and how to integrate the various strands has been shaped through his extensive experience. OFR are part of the STA's Special Interest Group, which is a leading and important programme of fire testing and research on mass timber. We aim to explain more on this as the forum series progresses. Mark Punsak is Assistant District Surveyor at the City of London. Mark is both a chartered structural engineer and a chartered building control surveyor. Other organisations and groups of which he's involved include being Vice Chair for the Institution of Structural Engineers Health and Safety Panel, part of the industry stakeholder group for STA Mass Timber Buildings Systems, a member of the Future of Building Control Working Group. Just some of the large iconic commercial building projects that Mark has been involved with include 20 Fenchurch Street, the Cheese Grater, the Scalpel and the Broadgate development. In a slight change to the fire testing and building control panel today, we are very pleased to introduce Professor Jose El Torero to this panel. Professor Jose El Torero is Professor of Civil Engineering and Head of the Department of Civil, Environmental and Geomatic Engineering at the University College London. Professor Jose Torero is an instructed expert to the Grenfell Tower inquiry. Now, he cannot, however, answer any specific questions regarding this because of his capacity in that role, but we very much appreciate him joining us today and value his knowledge and understanding with regards to fire engineering and mass timber commercial office buildings. He works in the fields of safety, environmental remediation and sanitation, where he specialises in complex environments such as developing nations, complex urban environments, novel architectures, new construction materials, critical infrastructure, aircraft and spacecraft. Just some of the many organisations of which Professor Torero belongs to include being a chartered engineer in the UK, a registered professional engineer in Queensland, a fellow of the Royal Academy of Engineering also in the UK, part of the Society of Fire Protection and Engineers in the US, the Institute of Fire Engineers in the UK, and the Institution of Civil Engineers in the UK. Finally, I can confirm that a senior member of the London Fire Brigade Fire Engineering Group is amongst the listening audience with you today. We look forward to hearing any feedback they have on today's discussions, and for everyone's information, they've been invited to listen and contribute if they wish to on any of the further sessions in the forum series. A huge thank you to all of our panelists for taking time to be here this morning. Matt, back over to you.
Great. Well, I think everyone can agree that's an amazing panel. We were joking before we came on air, actually, how many letters they've got behind their names. It's quite amazing. So, yeah, welcome everybody, and really glad to have you all on board with us. We're going to get into the Q&A in just a second. We're going to start the Q&A in relation to current knowledge and understanding during and post-construction. But what we thought would be quite good would be to make sure that everyone is awake first of all, and start with a poll question. These have been quite popular on our introductory session and on the insurance session that we've already run. So Ollie, do you want to start with this first poll question?
Yeah. Okay, hopefully everybody can see this on their screens. So this is slightly different than the other questions we've asked previously, because you can tick some or all of the boxes depending on your thoughts. So the question is, what elements of the design do you think are impacted by the incorporation of mass timber in offices? So is it any of these? It could be all of these or just a few of these. It's really up to you. Click away. Is it facade system, core, layout or form of structure, structure, member sizing, fire protection or connection detailing, MEP systems, acoustic separation, firefighting systems, for example, wet, dry risers, firefighting lifts, etc., fire suppression systems? As I say, feel free to select one or all of them. This is a slightly different format to questions we've had previously.
This is that awkward pause moment while you all answer it. We decided to have the pause rather than you get battered with more information, so you can actually answer the question.
If any of the audience does come up with any poll questions, we always encourage you to please send them through, and we really appreciate that. So please continue. Okay, hopefully everybody's voted now. I'll just read them out for everybody. So 79% of the audience said facade system, 62% said core, 100% said structure, including member sizing, fire protection or connection detailing, 50% said MEP systems, 71% said acoustic separation, and 71% said firefighting systems. So thank you everyone for voting this morning on that particular question.
Cheers, Ollie. Okay, so we'll link in from that for our first question. I mean, just to clarify, I mean, the clues in the title of the sessions, we are talking about mass timber construction here, because there's obviously many forms, but we're going to specifically focus on mass timber here today. So I'll go for my first question. How does designing a mass timber building differ from other types of construction? We ask Judith that one first.
So it's important to acknowledge that timber is combustible, clearly. So it can add a significant amount of fuel in addition to the fuel that's already in the building as combustible furniture and fittings. So when it is burning, it can influence the fire dynamics in that room. The other areas that are really important to consider are the unique material properties of timber. And I want to give you just some key figures on how that material changes as it heats in a compartment fire. Initially, it will dry out, it loses moisture, and it does that up to about 200 degrees C. And at that point, it then goes through an onset of pyrolysis, and that starts with the decomposition of hemicellulose and goes through to production of flammable gases. That occurs at about 270 degrees C, and when it heats further to about 300 degrees, you then see a char layer forming, which protects the timber and however can still continue to smolder behind the char layer, and that smoldering is a process whereby the fire continues to burn but you don't see flaming. Timber insulates very well, so you have typically a very steep temperature gradient through a cross section, in contrast to steel, which conducts heat very well. And the material properties of timber are also quite different to steel in terms of the strength it retains when it heats up. So steel, for example, loses strength from about 400 degrees, but retains 50% broadly when it is 550 degrees hot. With timber, when it's reached 100 degrees, it would have lost 35 and 75% of its strength in tension and compression, respectively. So it's really important as a designer to acknowledge that the material properties of timber influence the fire dynamics in the room, but also behave very differently at very different temperatures to, for example, steel and concrete. And when we see the product of timber being assembled in mass timber, they are adhered together in multiple layers, and that adhesive that's being used also has different properties when it heats. Some adhesives are not able to stick as well as others as they go through an extended fire exposure, which is what is then resulting in a phenomenon that's colloquially called delamination or glue line failure.
Okay, thanks. So, do you have anything to add on that?
Yeah, I mean, so is anybody getting any feedback? No? That's me. The thing I was going to go through is the misconceptions. Really. There's several misconceptions regarding fire and mass timber, which sort of permeate through the industry and can get in the way of rational sort of design discussions. Some of them include that mass timber is difficult to ignite. This is probably true in the early stages of a fire's development. However, sort of exposures that are broadly consistent with what we call a fully developed fire, which is basically a fire which has been allowed to progress and get to a stage where the sprinklers probably haven't done the job. At those kind of exposures, mass timber is relatively easy to ignite. The second misconception is that charring occurs at a predictable rate. Again, this is true in sort of idealised furnace testing conditions where you've got a very controllable fire size and a very controllable environment. And that's led to this sort of figure of 0.6 to 0.7 millimeters per minute being quoted. However, in real fires, the charring rate varies significantly, and it can evolve further with time, and it can change through the life of a fire. So it's a very complicated analysis, and it can also be complicated further by behaviour, as Judith explained about the delamination, where you start to see timber fall off. That dramatically affects the char rate. Another misconception is that mass timber readily self-extinguishes. It's true that if insufficient external heat energy is supplied to mass timber, the flaming will stop. However, at the scale of sort of typical office fire compartments, external energy can come from a variety of sources. It can come from timber walls, if you've got hot or burning walls, transferring energy to a ceiling, for example, beam connections, column connections. Now, once flaming stopped, as Judith alluded to, smouldering can continue for several hours behind the char layer, and that would require some form of fire brigade intervention to fully terminate the building, and it would be difficult potentially to establish when that fire is out. And another misconception is that timber is stronger than steel or concrete. This is a remark that's often bandied around, which again, it isn't technically correct. I mean, it's correct that timber chars and that this allows the structural element to withstand fire for potentially long periods of time, sometimes longer than steel or concrete elements. However, as Judith said, timber loses all strength over the range of 20 to 300 degrees. Below the char layer, timber can lose approximately 50% of its strength through drying alone, and comparably, steel retains nearly all of its strength up to about 400, and then loses strength rapidly between 400 and 600. And then concrete retains its strength at very, very high temperatures. So materials of different qualities and behaviours, and trying to make simple comparisons between timber and steel and concrete isn't particularly helpful or informative. And then the other thing is about the ban, really, but I think Jose's picking that one up.
Okay. Jose, do you want to add anything to that?
Yeah, I mean, I think that the issue that I think comes up after explaining all the different properties and differences between timber and other construction materials is, why do we need, to introduce bans, to certain materials? And I think we need to really understand what a ban is. A ban is a desperate action when you realize that you have absolutely no idea what you're doing, and that there is nobody that can actually design appropriately. And as you've heard from Judith and Sam, we know an enormous amount about timber behavior. Timber has been studied since the 1920s, and we understand quite well, how adhesives work. We understand quite well how delamination works. We understand quite well how self-extinction can be managed. All that information is there. Nevertheless, as you might have sensed from listening to Judith and Sam, this is a very, very complex problem, and therefore requires highly competent individuals, who have to deliver, the solution. Because the solution is not trivial. I think, with other materials, you might have simpler approaches that are accessible to a larger number of people. While with timber, the approaches are always complex, require a lot of detail, but we have the methods, we know how to design, we can do it. Therefore, a ban doesn't really make any sense. I think a ban, as I say, is a desperate action where you have no means, to address a problem. But in this particular case of timber, I think we do have the means, we have the knowledge. It is just simply accessible to a very small number of people. And therefore, we have to be extremely careful, on the way in which we contract people to make designs associated to timber.
Great, that's a great start, guys. Thanks very much for that. So let's bring Mark in. So Mark, in summary, can you explain what the current status of the building regs are in relation to mass timber, and specifically how does mass timber structures comply with Part B and the approved documents, and is there specific testing required? And above all else, are all the designs required to be fire engineered to justify it? I mean, it's a long old question, but just want to get an essence of a summary there, like the guys have done on the knowledge side, just on the reg side first.
So building regulations in the UK are performance based. So if I take up B3, for example, it says something like the building shall be designed so that in the event of fire, its stability will be maintained for a reasonable period. So, it's not material specific. Any material can be used as long as it can meet that performance standard. So the issue is really with how do we decide what's reasonable? And we have these approved documents which give some guidance. Now, the idea of the approved documents is they give some simple guidance for common building types. A lot of debate about what that actually means. But when you look into the history of the approved documents and the guidance in there, you find that the simple tables for fire resistance, for example, are based on tests from a long time ago of structure which is not combustible. So you have to ask yourself, does a mass timber building really apply to that guidance? Is it appropriate? So whilst mass timber is not at all banned or is perfectly okay, it goes back to that, how do you demonstrate that it's reasonable provision? And that's where we find some difficulties. So I think that you're always going to need somebody who's competent and who understands timber to be able to make that decision as to whether we can use a simple approach. Maybe we've got a very straightforward, simple building, which we don't mind if it burns to the ground, for example, after everyone's out. And we can use a simple system for that. We may have a more complicated building where we need people to stay in for longer, or it's difficult to firefight. And we need to have more confidence in the ability of the structure to stay up. And that's where you really need the real competent engineering input. As to testing, perhaps we do have some complicated design methods that we can use, but there is no simple method. So testing can help to do that demonstration, particularly where you might have a novel structural system or layout that perhaps we don't have full knowledge about how that might perform, and that's where testing can come in to help inform how is this going to perform in real life, and is it going to meet that performance-based standard?
So just generally, then most projects you're dealing with mass timber do involve fire engineers and fire engineering solutions to justify.
Yeah, I think it would be a fairly small, simple project that didn't need a fire engineer. And to be fair, you need a competent person to make that decision about whether you need a fire engineered solution. And you know, those people are people like the fire engineers or maybe a competent building control person who can make that decision. So I would say you need a fire engineer involved somewhere along the line.
Fantastic, thanks for that. Okay, so it's asked Sam and Judith, Sam and Jose this one. Is the fire engineering design approach different for hybrid mass timber developments, as a number of our people on the call will be involved with, as opposed to all mass timber construction? And can you differentiate also between an extension to an existing building or, say, a new build? Sam, can you pick that one up first?
Yeah. I mean, introducing mass timber into a scheme and allowing it to contribute as a source of fuel presents specific hazards, those we've addressed so far, that need to be addressed irrespective of whether the building's pure timber, whether it's a hybrid, whether it's an existing building with an extension, or whether it's completely new build. The same complications arise in all forms of construction where timber manifests itself. So hybrids have benefits, and existing buildings with extensions I would put into the sort of hybrid category. They have benefits in so much that they often make better use of the qualities of materials. So using steel and concrete for columns in high-rise buildings, or concrete for cores. These offer some sort of additional robustness to the fire strategy, as we know that those elements can be designed relatively simplistically, and we know that they will not be consumed in a fire. So we can sort of build the fire strategy around those non-timber elements. Hybrids do introduce challenges, particularly interfaces and in the specification of products and materials. So, for example, where steel is supporting CLT, i.e. steel beams with CLT slab, incompatibility can arise regarding how the steel is fire protected. So if it's intumescently protected, intumescents in close proximity to timber aren't necessarily very well tested or particularly well validated by the industry. It doesn't mean we don't understand what the concepts are, but they're not particularly tested. So this both impacts on how you specify the extent of protection. Is it all sides? Is it only the sides that are exposed? And certification. And with certification comes warranty issues. So what confidence does the supplier have of the performance of their fire protection product when used in proximity to a combustible material? Will they provide a warranty? And addressing those questions are often motivation for looking at project-specific testing, which is what Mark just stated.
Great, thanks, Sam. Jose, do you want to add anything to that?
Yes, I think that again, we go back to fundamentally the same point. Now, the use of hybrids, the use of different materials together, the working with existing buildings, all these things, bring challenges and complexities, but they also bring the capability to come up with an optimized design that is the best for the site that you're working with and the requirements, of all the stakeholders. So in principle, these are all variables that an engineer will play with in the process of design. And in that sense, there is really no difference. I think the problem is that when you start linking all these different things, once again, you start requiring a higher level of versatility and competency from the engineers that are actually working in these projects. And because it's not only understanding timber, but now you need to understand, for example, historic context, for a building that existed, or you need to understand issues with other materials, interactions between protection. All these things start piling up, and I think that while we have to seek these opportunities and try to make the best solutions for our projects and use whatever formulation is ideal or optimal, for what we're trying to do. We always have to be extremely careful that there is consistency between the complexity of the project that we're dealing with and the individuals who are conducting the design. And I think it becomes a very interesting problem for those people choosing contractors to try to understand who knows, all the things that need to be known in this particular type of projects.
Thank you. So Judith, how would you say the role of a fire engineer differs on timber buildings in comparison to other structures? take yourself off mute.
So as for any project, it is fundamental to have the required competency to inform the fire safety design approach and the safety decisions that are going to be made in that project from the very early inception stages through design, through specification of details and the construction and the constructability, including handover. So I'd say that the role as such isn't different to any other project where a fire engineer is involved, but the knowledge that is needed is very different and is largely written in research papers and publications rather than standard guidance that the common engineer might draw to inform designs. So it's really important that the fire engineer working on timber buildings understands how the material behaves in fire and how it does that in relation to other materials that timber might be combined with, the protection measures that are available for timber and their limitations in terms of testing for the proposed application, which then informs a test plan that might be needed for the project specifically. And just to give you an example of why that matters, in Europe, for example, there is a timber protection classification commonly used called the K factor that doesn't appear in any of the UK guidance documents. So it's not something that the industry here is particularly familiar with. So there is, I guess, an element of education that often happens where the fire engineer does spend quite a lot of time informing the rest of the design team of some of the measures that are needed, which is why it is important that it's not just the fire engineer that is competent, but actually the whole design team, because the structural design will be different, the acoustic design will be different, and to be fair to everyone who's contributing to the design of that building, it should really be a competent design and contractor team as a whole that proposes the fire safety design solution and other solutions.
Right. Jose, did you want to add anything to that?
Yeah, just briefly. So effectively, in every design process, there will be an application of a series of methods that could be within guidelines, or it could be part of the competency of the professionals who are working. And as Judith has said, we're not talking only about fire engineers, but there's multiple interactions between different professionals. So all this team has to basically be able to use these methods to deliver the design together and to come up with an optimal solution that meets all the requirements of every one of the stakeholders. So in principle, that's the way we operate. Now, if we have a very, very simple design, then all these methods are very well known, they're tested, they are inscribed in guidelines with very, very simple solutions that pretty much almost brings us to the point, in the case of prescriptive design, of a checkbox. So we can actually follow that, and therefore the level of competency of the ensemble is actually there, but is limited in the sense that everything is written in black and white, and you can just simply follow one document and come up, with all your design decisions and interactions. Now, with the case of timber, the problem is, as Judith said, the people that are working in this project have to resort to research papers, have to go to a number of different places because there are gaps of knowledge. Now, those gaps of knowledge doesn't mean that we cannot design. We can perfectly design, but we have to do it conservatively, and we have to do it using big, safety factors and so forth. And those nowadays, then they're not inscribed in guidelines. They're not, part of your regular methods that people use. They're not conventional. And therefore, there is a process by which the designer has to educate itself and be able to deliver the solutions, but not only educate itself, but it has to educate the people working, with this designer, because the other ones need to understand why certain decisions are being made. And that, for example, requires a much higher level of trust. So you have to trust the professionals that are working with you, that they know their own discipline. So in a way, the difference is that you are operating in an environment where the professionals have to have a much, much higher level of trust. And also the professionals have to have a much higher level of competency to be able to circumvent all the gaps of knowledge and deliver a design that is robust, maybe conservative, but nevertheless delivers in an optimal way of all the objectives of the design process.
Thanks, Jose. Okay. The BCA guidance is suggesting a peer review process on mass timber products similar to that of other structural design such as bridges, etc., whereby peer reviews and checks are required. So, Mark, who do you think is best placed to undertake the reviews, and who should be in charge of appointing them?
I mean, these peer reviews are really quite an important point in ensuring that we can have some confidence in designs, and it's something we do a lot where we have maybe novel design or something where a design's not a codified approach. So there's two key points to somebody who's a peer reviewer, and that's independence and that's competence. So obviously they need to know what they're doing, they need to be really competent in the field which they're doing the review, but also they need to be independent of the process. So in an ideal world, it should be appointed either by building control or by the design team in conjunction with building control, so that the building control body is actually really happy that peer reviewer is competent and is independent of the process. So a peer reviewer in this case is not probably somebody from the same fire engineering company who's doing the design. This is really an independent peer review we're talking about here. I mean, in terms of who's best placed, it is about that competence and that understanding. And I would say at the moment we don't have masses and masses of people out there to do this for us. So, you know, there's probably a handful of consultants who can do this really well, but there's some really good people in academia who can demonstrate that they know really well what this is and therefore also be really independent. So, yeah, there's some people out there who can do this really well. I would suggest that, you know, if it's complicated, an academic is a really good person to do, and that it should be appointed via building control or with building control.
Okay. So Sam, anything to add to that?
No, I mean, not really. I think Mark's covered all the main salient points. I think one thing that, and I know we keep going on and on about it, but you know, not all fire engineers are equal in terms of their understanding of timber, and I think not all peer reviewers are either. So I think that we have to be very selective about who designs and who peer reviews. And I think the other thing that's important to mention, I think, about the peer review is that once it's been decided that a project is sufficiently complex to require peer review, it's important to set out the parameters at the start of what that peer review is going to look at and what level of reliance is going to be placed on the outcomes of that peer review process by the approvers, so by the building control and by LFB. It doesn't make a huge amount of sense to invest the money and time in bringing on a peer reviewer to then basically not accept any of the findings. So it has to be done with a sort of open book. We're all going, you know, all these discussions are transparent. It's all been discussed. We've seen what's been discussed. But ultimately, if the peer reviewer says they're satisfied with the way the design's been done, that should be sufficient for the approvers to be able to rely on that.
Great. It's really good that Lindsay Seal has actually sent us all a chat message as we've been talking on this very subject, which is great. So thank you for that, Lindsay. It links in well. Okay, Jose, did you want to add anything to that before we move on?
I mean, I want to follow on Lindsay's point, actually. I think that's absolutely correct. I think that you know, there's a couple of things in there. I think at the end, the ultimate objective of a peer review is to have confidence that the design is an appropriate design. And in the case of timber, because of the nature of the process and the fact that you have to work with generally ad hoc and unique solutions, and you have to implement a high level of knowledge, you know, the process of peer review, while remaining independent, can be a very collaborative process that can start very early on and can have multiple dialogues between the designers and the peer reviewer. And furthermore, I mean, it can actually comprise of more than one stage where you can have one peer reviewer that operates in a collaborative way, you know, with the designers working through the best possible solutions, and followed by another peer review, which is just a validation process where effectively somebody's looking completely afresh at the process and saying, well, you know, I'm confident that they've come up, you know, with a design that is appropriate. So in a way, I think we have to look at peer review when it comes to mass timber buildings with a little bit of flexibility and focusing very much on the objectives, which is actually delivering, the appropriate design, and all the parties need to work in a very collaborative way, which is in general quite different to your traditional peer review when the methods are more conventional, and you have only the sort of validation stage, of the peer review, which is fully independent and comes at the end, of the process.
Great, thanks for that. It's just linked back to our insurance panel, and when we did that 4 weeks ago. So just referring back to that session, they were asked if the industry differentiated between timber products. Oliver Wright, the construction risk consultant at Aviva, said that every product is viewed on its own merits. Despite the wide range of timber products out there, fire is still the main risk. So ask this question to Sam first. How do fire engineers and building control consider and or assess different timber products? You pick that up first, Sam, and then we'll ask Mark.
Yeah, okay. I mean, there's lots of different types of timber products, but there's often a temptation to lump timber structures under a single definition, and then obviously by extension a single stigma. Light timber structures, light timber composites such as SIPS panels, and mass timber behave very differently, despite all being combustible. Many larger fires with extensive fire spread have occurred in light timber frame buildings. Such buildings have a complex array of interfaces, voids, features, etc., whereas fire can spread unseen if the specification, detail and implementation, how it's actually built and management hasn't been adequate. So that's not to say mass timber is not immune from such issues, but currently there are very few salient examples of significant fires in mass timber buildings. So from the insurance perspective, they have to act on current knowledge, and the knowledge largely pertains to the types of timber that we're not talking about here. An important step in averting those events is to ensure that not only is the fire engineer competent with relevant experience, but they're engaged in sort of realising the clarity, looking at the detailing, looking at the specific fire safety detailing of interfaces, of facades, of structure, and looking at what the actual outcome of that needs to be. It can't be a prescriptive, all timber structures must be like this. It has to be, they all have to perform in such a way. And the fire engineer has to look at those very nitty-gritty details and not simply just say, well, it's a mass timber building, we'll get self-extinction if we do this, and then leave it up to everybody else to deal with.
Mark, you got anything to add to that?
Yeah, I think we've got an interesting situation with this. Where we're maybe assessing a steel structure, we've got a good codified approach. It's a fairly homogeneous material. We can ask for mill certificates and test certificates and understand what the properties of that steel beam are, for example. When we have mass timber, it's a variable material, and each manufacturer will put it together in a different way, maybe using different adhesives. So I would treat it more akin to a product at the moment. And like any other product, a different intumescent paint material or a fire stopping product or a fire damper, you'd be looking for the quality assessment of what that product is doing and what the tests are to back that up. So I think that's how we'd go about it at present, and until and unless we get some kind of product standard or that kind of thing that we can assess against.
Okay.
The important sort of point about that and this product assessment as opposed to material performance is it needs to be looked at as to whether we believe that that particular detail satisfies the functional requirements of the building regulations, i.e. is it adequate, does it provide adequate structural protection, not is it going to achieve 60 minutes, 90 minutes, 120 minutes, because we simply don't have the test basis for timber to be able to apply generic performance criteria to generic details. There is no such thing as generic when it comes to timber.
Thanks for that. Okay, so following the theme, just linking back to the insurance piece now. So it was clear that the risk and impacts on fires on timber buildings is a key factor resulting in high insurance premiums or relatively high insurance premiums. There are concerns that are related not only to life safety of occupants, but also impacts to the structure following the fire, such as charring and the need to make significant repairs post-fire events. I know that this is going to be a fairly short answer, but what are your thoughts on this and on this concern, and is there anything that can be done to mitigate it? So Sam, do you want to pick that up first?
Yeah, I mean, it's a legitimate concern. Ultimately, insurers want an appreciation of the risk that they're underwriting. And there is an element of the unknown with regards to a loss that can be expected from mass timber. As I said earlier, there are very few examples to call upon. This often means that the insurers have to sort of defer to experience from fires involving other types of timber construction, and it's important to differentiate between the different types and not extrapolate experience necessarily from one type of timber construction to the others. But ultimately, it's the responsibility of the industry, the people on this call, to generate the knowledge required for the underwriters to make more informed decisions. Research projects such as the one that we're leading on behalf of the STA are going to help some of that. But ultimately, it's our responsibility to create sufficient knowledge for the insurers to be able to assess it adequately.
Okay, so actually, we'll move on to the next question, if that's okay. We'll just in terms of time. They also mentioned concerns over how quickly fires progress in timber buildings and delamination causing a second phase of fire. Can you describe the fire dynamics with timber buildings and how issues like this can be prevented and mitigated? Judith, do you want to pick that one up first?
Sure. So there have been overall over 30 compartment tests with some degree of CLT exposed in the UK and internationally, and from that we do understand that there's 3 types of fires that can happen when there is exposed CLT. One is that the fire initially grows, it then reaches flashover, which is a point in time when the whole room is on fire at the same time. You've got then char layer forming on the CLT that protects the timber, and if the contents have burnt out, the fire can then reach a decay. Overall, the fire can be longer, particularly in the decay phase. The heat release rate can increase with increased exposed timber, which can also lead to a greater amount of flaming on the outside of the room. The second type of fire that can occur is that it grows, it reaches flashover, and it then just keeps burning. Like it doesn't go out until the whole amount of combustible material, the insides of the room and the combustible structure is consumed. Or the third type of fire that can happen is we've got fire growing, flashover occurring, char layer forming, and then the char failing, and with certain types of adhesive that has been observed. And when that char starts to fail, it brings fresh timber into the combustion process, which then adds new fuel. The fire can then regrow until we've got new char forming. The fire might then go out, the char might then fail, and the cycle can repeat. And that is an unpredictable decay process because there isn't enough knowledge out there at the moment to really understand how that works. So it is really important when designing with mass timber, particularly for tall buildings where we need to have confidence that the structure is able to withstand burnout, that we reach a predictable decay in the design fire. Ways that as designers we have available to us to achieve that is to either be very conservative and encapsulate the timber to a degree that it actually doesn't become part of the fire in the first place. Or there's other choices that as a designer you could make in terms of limiting the amount of timber that is visible and hence becoming part of a fire. Using a type of mass timber that doesn't display the delamination behavior. There are products out there that don't do that in the first place. You can add additional safety layers to the design that maybe aren't normally expected in a common building, such as sprinklers or additional firefighting measures, or add non-combustible structural elements as a additional safety measure, for example, building cores and certain critical floors out of non-combustible. So there's a variety of different tools available that that as a designer we can use to derive a safety concept for timber. What is important in all of this though is that these tests have been done in compartments that have never been greater than 84 square meters. So when it comes to really large spaces, there haven't been tests done yet with exposed CLT in very large compartments, which is what offices typically are. So that is an important area of needing additional research to understand the fire dynamics in those very large spaces.
Okay, that's great. Sam, I know you probably wanted to add something to that, but we're running slightly, well, we're running behind. So if we move on, if that's okay. The insurers also highlighted that the quality of the contractor and subcontractor is important when they're considering their fire risk assessment, their risk assessment. What are your thoughts on this, and how might this link to your design discipline? I'll ask that of Judith first, and probably get a comment from Mark on that as well. So Judith, I don't know if you want to pick that up.
It really comes back down to the competency again. With timber construction, the detailing is critical, the protection provisions is critical. They're often not common products, so it is important that the contractor and associated subcontractor really appreciate the importance of all these aspects, because they're there to provide a safe design solution for a structure that in itself could potentially contribute quite significantly to a fire. So it's coming down to competency again.
Okay, Mark, agree?
Yeah, I absolutely agree. I mean, I think from a building control point of view, we have a minimum level of input we have to have, but where we're concerned about the level of quality that we see, or the level of control that we might see, we would up our level of input and our demands, if you like, in terms of what we were seeing and what quality measures we wanted, and that's going to feed back into the fees that building control need to pay and to be paid and that kind of thing. So the better the quality on site and the better the level of control, the better for everyone, really.
Okay. All right. Some quick fire questions now. So the insurance mentioned the benefit of a tick box style design guide to help identify the key factors that should be incorporated into mass timber design in order to make the insurers more comfortable. Sam alluded to that earlier, actually. This would give owners, developers and designers a clear starting point and reassure them that if certain designs are that certain designs are incorporated. I think I know the answer to this one, but Sam, do you want to pick this up? Can this be achieved, and is there a code of practice? You've mentioned it before.
Yeah, there's currently not a code of practice. We understand that the FPA is drafted guidance on insurers, on fire and mass timber. I think it's important to point out that any guidance that is drafted should be an outcomes-based guidance, i.e. has sufficient rigour gone into the design, has an adequately competent design team provided the design, has it been adequately approved by the right steps, etc. It can't just be what percentage of the timber is exposed, X, Y. It's got to be outcomes based for it to be successful.
Great, thanks for that. And Sam, again, just on the existing data and findings of recent test data, can the existing data and findings of recent test data be provided to designers, approvers and the insurance industry to help avoid the need for costly and repetitive testing?
Yeah, this is a matter of IP predominantly. Not all testing that's been done is publicly available, and some of it is owned by the labs and licensed back to suppliers. Some of it is owned by particular clients or particular suppliers. Judith mentioned that the CLT tests that have been done to date, a lot of those are publicly available, but as she said, the use of them is incredibly limited. Not just to the size of the compartment, but to the build of the compartment. Most of them are just timber boxes, which is completely irrelevant to how timber is typically used in design. So there is an STA project that we're doing, I'll take you through it in a minute, to public, and we're going to look at an extensive review of what the current testing is, and we're going to do some testing at a large scale to go forward. And that the intent of that is that it will assist designers, it will be publicly available, and it will start to inform designers going forward.
Thanks, Sam. Ollie, do you want to whiz through our next poll question? We're running slightly behind, so if you want to just whiz through.
Yeah, I'll do this quickly. So there's two questions to this, please, everybody. So question one, how urgently do you believe investment is needed to create a dedicated standard to enable mass timber construction to be adopted? Is it very urgent, in brackets, as soon as possible? Is it reasonably urgent? That's 3 to 5 years. Is it not urgent, so 5 to 10 years or more, or not needed at all? And the second part to this question is who should fund this work? Who's going to pay for all this? Should it be funded via projects individually? Should it be funded by mass timber suppliers? Should it be funded independently by government? Or is there another source that should pay for this? If you could try and tick one of those boxes in both questions, please, and let us know as soon as possible.
So while you're doing it, I'll actually ask the next question just so that we can save a bit of time whilst you're ticking those boxes. So this will be one for Sam. What is the industry leading source of data? And in your view, what needs to happen for the industry to formulate a single source of data? So if you can just be pondering that, Sam, and then we'll answer that when the answers are in on this latest poll.
Okay, so answers are back. So question one, 86% said very urgent, so as soon as possible. This is something that needs to be sorted out ASAP. 14% said reasonably urgent, so in 3 to 5 years. Nobody said it, 0% said not needed and not urgent at all. So I think that's quite clear on urgency about this information. And then part two of the question, who should fund this work? Via projects, only 3%. Should it be funded by mass timber suppliers? 42%. Should it be funded independently by government? 47%, and another source was 8%. So it's quite clear there that it should, a bulk of the audience think it should be funded by mass timber suppliers and independently by government.
Interesting. Okay. So Sam, do you want to pick up on the question asked during that poll?
Yeah, I mean, there is no single source of data at the moment. There's a collection of supplier-specific test reports, European technical approvals, trade literature, academic research, etc. So there's no single source. I mean, often the most valuable sources of data come from academia. In the case of CLT, that's largely the case. But for a single source of data to exist, there has to be various things. There has to be a collective organised effort to organise and fund research and development, and then those findings need to be published. The STA project is an example of this, but it can't answer all the questions. There has to be a collective desire amongst all mass timber manufacturers to make available their test data. And there has to be probably a trade body that represents the mass timber industry to host that data. Currently, there is no specific ownership. The interest is spread across the STA, TRADA, UK, TFF. There's a disparate source of sort of responsibility and a disparate source of information.
So just on that, you mentioned the STA there, their current programme. Can you just give an overview where they're at the moment?
Yeah, I mean, it's interesting because if you look at the answers to those two questions that have just been answered, something like 70-something% said that the desire for standardisation was urgent and needed to be done immediately. And for something like 52 or 48% said that it should be funded by government, 42 said it should be funded by the UK industry. The reality is, having something urgent to be done by the government fundamentally don't align. So the industry themselves have clubbed together, and between the three largest UK timber suppliers, who are KPF, Binderholz and Stora Enso, they've pooled resources and put something like £500,000 to sponsor a large-scale test regime. So the STA programme, it's an 18-month project. It's being led by Dr. Danny Hopkin and Dr. Michael Spearpoint from OFR on behalf of Stora Enso, KLH and Binderholz. And then there's separate oversight from an independent group of stakeholders, which includes other fire engineers, it includes MHCLG, leading academics such as Jose, such as University of Edinburgh, fire service are on that steering group, and other interested stakeholders as well. So there's sort of 6 work packages which go from the development of a compliance framework. What does compliance for timber buildings look like? Is it the application of the guidance? Probably not. Are there specific things that you can short circuit and do in each building? Yes, there probably are. We're going to be looking at a large scale review of the literature, what's been tested so far. As Judith alluded to earlier on, there are CLT tests. They're not particularly relevant, but they do give some information which can be used to inform the next round of testing. And then we're going to be looking at comparison of product performance against various different suppliers. We're going to be looking at, and then we're going to do an extensive process of large scale testing for both office and residential uses. That will conclude in about 18 months. The report will be issued and it will be made completely publicly available for free to all stakeholders in the industry. So we're about 6 months into that 18-month program at the moment. We're due to start testing in about 3 or 4 weeks.
Fantastic, thanks for that update. Okay, we need to speed through these next couple of questions. So specifically in relation to mass timber, how do fire engineers and building control currently engage with the LFB? I want to ask that question because obviously Lindsay's been communicating with us as panelists during the session here. So I'll ask that of Judith first.
It's in the same way as you do for other projects where you have an unusual design proposal that is maybe perceived to be high risk, or there's greater levels of concerns. So as early as possible to make sure the concerns are put out in the open and discussed, openly and honestly with everyone to work through those issues. Okay. And I'll let Mark follow on process and procedural aspects.
Yeah, there's a formal process to go through at the point of a building regulations application, but really that's a bit late in the day on something like this. So I agree with Judith, it needs to be really early in the process. But we need to make sure that is done via building control. What needs to happen is that you need to engage with building control really early, get the principles designed with and agreed with building control, and then go to the fire brigade. And Lindsay just made a really good point. It's not just London. This could happen anywhere across the country. Not all brigades have an engineering team or anyone with that sort of knowledge. So we need to make sure that that the principles are all agreed with building control before you go to the fire brigade. And because we want to go to the fire brigade early in the project, you've got to get building control really early in the project.
I've been looking down my list of questions and needing to be selective given time. So this one I think is one that a lot of people on the call will be interested in particularly Judith and Jose's view. What can we learn from the way other countries are approaching the design of mass timber buildings? And is this information being shared? So Judith, do you want to pick that up first, and then Jose, do you want to pick that up after?
Yeah, sure. So I do disagree with Sam's statement that the tests that were done internationally are not relevant. There is a lot to be learned from it. US and Canada have invested for a decade or so into fire safety of timber. That has allowed them to change their product standards for CLT to require non-delaminating CLT to be used in all buildings from 2021. And they have also made updates to their international building code and the national building code in the US and Canada respectively to give specific guidance on how you construct with mass timber. And as the building height increases, there is an increasing level of conservatism in those design rules in terms of the level of encapsulation that's required to those building designs. It's important to recognize that there are fundamental differences in the standards. So the US will sprinkler a lot earlier. They will not have single stair residential buildings. They will not have stay put type alarm type systems in the buildings, but they do have a safety framework now in their standards that acknowledges mass timber to a greater degree. And that has seen an increased interest in building with that material as a result of that increased certainty that's now available to designers and insurers. It's also important to recognize that research was often funded by government and insurers, and is published, it's out there, and it's something that in Arup we have reviewed in great detail to inform a design methodology that we are adopting when designing with mass timber to take into account where there are still gaps, and then applying appropriate safety considerations to arrive at design solutions that we think are appropriate at this point in time for mass timber.
Great. Jose, you've got about 10 seconds to add anything to that.
Yeah, just very briefly, I mean, I think that the information is to a general extent available. There's information that comes from all over the world. And some of it remains proprietary, but the majority is available and accessible. The problem with the information is that you don't really know exactly what the motivation of the work was. And there's a very big difference between demonstration tests, which are designed and built to convince people about something, in which cases we are reducing measurements, hiding information, sneaking, images into people's minds, and information that is done for research. And the problem is that the mixing of the two has created a massive confusion. And the perfect example of that is the problem with the adhesives. So all this massive confusion is created by the fact that you have people trying to push ideas and doing demonstration type of work and mixing it as if it was research, with people actually doing research and trying to show the reality of the problems. And I think we just have to sieve the information very carefully and make sure that we are making decisions accordingly.
Thanks, Jody. Right, we need to wrap up there, I'm afraid. We have a number of other questions that we will pick up during our report, and we'll pick up in the report, and indeed the live questions that have been raised, we'll also pick those up in our report as well. So again, thank you all for your time this morning, and thank you all for our panelists. I thought they were excellent. Next up will be our sustainability panel. So you can see who got involved there, some very, very well-known names in industry in relation to that. So we look forward to welcoming them to that session. Next slide, please. And then don't forget to give us any more questions for that session. If you want to email those to Ollie, that'd be great. So I think that's about it. I mean, just in summary, I picked up the words complex, competency, consistency, conservatism, collaboration, all seem to be beginning with C. So that's what I picked up. Anyway, thank you all for your time, and apologies we couldn't get through all the questions, but we'll pick those up in our report. Thanks very much, everyone. Goodbye.